Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children. I've shared my screen. Is it visible?
Yes, ma'am.
Yeah. Please start writing along with me. Yeah, when I'm explaining, please stop working. Please stop writing. So when I'm not explaining, you can continue writing, children. Yeah. Now listen to me. A quadrilateral is a closed figure obtained by joining 4 points in a plane of which no 3 points are collinear. So consider these 4 points in a plane. Okay, so we have 4 points in a plane. Now, all these 4 points can be connected by the same straight line. So though we have 4 points in the plane, the points are collinear. So no quadrilateral is obtained. Now, take this case. We'll take 4 points. Okay. Like this. In the first case, all the 4 points can be connected by the same straight line, meaning the 4 points are collinear. So though we have 4 points, no quadrilateral is formed. Let's take the points like this. So here 3 points are collinear. 3 points are collinear. 3 points are collinear. And 1 point is away. So when you connect these 4 points, a triangle is formed. But for a triangle, you don't need 4 points. 3 points are enough to form a triangle. To make a triangle, the 3 points should not be collinear. We need 3 points to form a triangle, but the 3 points should not be collinear. If the 3 points are collinear, no triangle is formed. No triangle is formed. If the points are not collinear, if the 3 points are not collinear, then by joining the 3 points in order, a triangle is formed. You have 3 points. See, 2 points, the term collinear is not used for 2 points because 2 points can always be connected by the same straight line. When you have 2 points in a plane, you can always connect them by the same straight line. So the term collinear is used for 3 or more than 3 points, not for 2 points. The term collinear is used for 3 points or more than 3 points, not for 2 points, because 2 points can always be connected by the same straight line. So to form a triangle, we need 3 points in a plane. And if the 3 points are collinear, no triangle is formed. We need 3 points. And if the 3 points are collinear, no triangle is formed. But if the 3 points are not collinear, then you can join the points and form a triangle. In the same way, to obtain a quadrilateral, we need to consider 4 points in a plane. If all the 4 points are collinear, no quadrilateral is formed. If 3 points out of 4, if 3 of them are collinear, no quadrilateral is formed. Here all the 4 points are collinear. Here 3 points are collinear. Of the 4 points, 3 points are collinear. No quadrilateral is formed. So now see this. We'll place 2 points like this. So here you see that no 3 points are collinear. No 3 points are collinear. Consider 3 points. Consider any 3 points. They are not collinear. Only in this case, by joining the points in order, a quadrilateral can be formed. In this arrangement, we have taken 4 points, of which no 3 points are collinear. When you consider 3 points, you can see that the 3 points are not collinear. Consider any 3 points. They are not collinear. Only in this case, a quadrilateral is formed. And you should connect the points in order. See, if you connect like this, no quadrilateral is formed. You must join the points in order. You must join the points in order. So in order meaning, see, a quadrilateral is formed. So a quadrilateral is a closed figure obtained by joining 4 points in a plane. 4 points in order. In order, okay? In a plane of which no 3 points are collinear. Show you this again. When all the 4 points are collinear, no quadrilateral is formed. No quadrilateral is formed. Like when 3 out of 4 points, when 3 out of 4 points are collinear, no quadrilateral is formed. No quadrilateral is formed. So when 3 out of 4 points are collinear, 3 points are collinear, like say 1, 2, 3 like this. The 4th point is away. So when you connect, you get a triangle, not a quadrilateral. So when 3 out of 4 points are collinear, no quadrilateral is formed. When no 3 points out of 4 points are collinear, a quadrilateral is formed. A quadrilateral is formed. When no 3 points out of 4 points, when no 3 points are collinear, a quadrilateral is formed. When no 3 points out of the 4 points, when no 3 points are collinear, when no 3 points cannot be connected by the same straight line, then a quadrilateral is formed. So like 1, 2, 3, 4. You can take any 3 points at a time. You will see that they're not collinear. In this case, a quadrilateral is formed. And you must connect the points in order. You can see the quadrilateral. Write down, children. Please write down. Finished writing, children?
Done, ma'am.
Okay. All right. Next one. Now talking about the types of quadrilaterals. Types of quadrilaterals. So first we'll talk about kite. A kite is a quadrilateral. A kite is a quadrilateral in which two pairs of adjacent sides, are equal. So see here. So ABCD is a kite. ABCD is a kite because as we can see, adjacent sides AB and AD are equal and adjacent sides BC and DC are equal. A kite is a quadrilateral in which two pairs of adjacent sides are equal, not opposite sides, adjacent sides, next sides. AB and AD, adjacent sides are equal. BC and DC, adjacent sides are equal. So such a quadrilateral is called a kite. In a kite, opposite sides are not parallel. That's the most important feature. In a kite, opposite sides are not parallel. Okay. Opposite sides are not parallel. Diagonals meet at right angles. Diagonals intersect at right angles. Intersected right angles. The longer diagonal bisects the smaller diagonal. The longer diagonal bisects the smaller diagonal. So here if AC is, supposing AC is the longer diagonal cuts the smaller diagonal into two equal pieces. Supposing the longer diagonal is AC, then AC cuts BD, the smaller diagonal, into two equal pieces, which means OB is equal to OD. O is the midpoint of the smaller diagonal BD. O is not the midpoint of the longer diagonal AC. If O is the midpoint of both the diagonals, then it means the diagonals bisect each other. In a kite, the diagonals don't bisect each other. The longer diagonal bisects the smaller diagonal. That means the smaller diagonal is cut into two equal halves. So if BD is a smaller diagonal, O is the midpoint of BD. O is not the midpoint of AC. Now, since this side is equal to this side, this angle will be equal to this angle. So angle 1 is equal to angle 2. And since this side is equal to this side, this angle is equal to this angle. All right. So we have angle 1 equal to angle 2 and angle 3 equal to angle 4. So what is angle 1 plus angle 3? Angle ABC. Angle ABC is equal to angle 2 plus 4, ADC. ADC. So in a kite, one pair of opposite angles are equal. The other pair will not be equal. The other pair of opposite angles are not equal. One pair of opposite angles are equal. In a kite, one pair of opposite angles are equal. One pair of opposite angles are equal. Write down. I need to take the next slide. Please write down. That is IE, meaning that is one pair of opposite angles are equal. That is the angles at the ends of the smaller diagonal. The angles at the ends of the smaller diagonal. The smaller diagonal is BD here. So here angle B is equal to angle D. It's always like that. The angles at the ends of the smaller diagonal will be equal. So we said one pair of opposite angles are equal. So which is that pair? The angles at the ends of the smaller diagonal are equal. Now we have the other pair of opposite angles, right? The other pair of opposite unequal angles, because one pair of opposite angles are equal. The other pair of opposite angles are unequal. That other pair of opposite unequal angles, they are bisected by the longer diagonal. They are bisected by the longer diagonal, meaning this angle, this one, this angle is equal to this angle, and this angle is equal to this angle. They are bisected. Whereas this pair of opposite angles, which are equal here, which are equal, that is angle B is equal to angle D, right? Here. These angles are not bisected. The opposite angles are equal. This whole angle is equal to this whole angle. This whole of angle B is equal to whole of angle D. Opposite angles are equal. Those angles are not bisected. They are not bisected. The other pair of opposite unequal angles. Now angle A and angle C, they'll not be equal, but they are bisected by the longer diagonal. So the equal angles are not bisected. The unequal angles are bisected. The equal angles are formed at the ends of the shorter diagonal. The unequal angles are formed at the ends of the longer diagonal. We'll go through the properties again. Please finish writing and let me know. Children, use the emoji. Raise your hand. Bhavashya, Laksha, Sadhna Sabarna, Krishna Priyan, Niveda, Aragammai, Hariharan, Prenu, Sahana, and Srivatsan. Very good. Thank you, children. You may lower your hand. Finish writing? Okay. Now, PQRS is a kite because PQ is equal to PS and QR is equal to SR. So PQRS is a kite. Opposite sides are not parallel in a kite. That is PS and QR. Opposite sides PS and QR are not parallel. They are not parallel. The opposite sides PQ and RS, they are not parallel. So a quadrilateral in which no pair of opposite sides is parallel is a kite. So in a kite, we have adjacent sides equal, two pairs of adjacent sides equal. The diagonals are unequal. The diagonals are unequal. The diagonals are perpendicular to each other. Diagonals are unequal. I'll just insert it here. I think I forgot to write that up. Okay, diagonals are unequal. Okay, so diagonals are unequal. Diagonals intersect at right angles. The longer diagonal bisects the shorter diagonal. The angles at the ends of the shorter diagonal, the angles at the ends of the shorter diagonal are equal, but they are not bisected. The angles at the ends of the longer diagonal, at the ends of the longer diagonal, they are not equal, but they are bisected. So like if supposing this is 100 degrees, it will be 50 here and 50 here. And supposing this is some 60 degrees, it will be 30 here and 30 here. So that pair of opposite angles which are equal are not bisected. The pair of opposite angles which are not equal are bisected. So where do we find the pair of opposite angles which are equal at the ends of the shorter diagonal? And the pair of opposite angles that are unequal are at the ends of the longer diagonal. So one pair of opposite angles equal, one pair of opposite angles unequal. Equal angles at the ends of the shorter diagonal, unequal angles at the ends of the longer diagonal. The equal angles, they are not bisected. These two angles are equal, but they're not bisected. Like it can be 40 here and 60 here. They're not bisected. But the pair of unequal angles, opposite unequal angles, the angles are unequal, but they are bisected. So this can be 100 degrees, this can be 60 degrees. The opposite angles here are unequal, but they're bisected, 50-50, 30-30. So very important, in a kite, both the pairs of opposite sides are not parallel. A kite is a quadrilateral in which two pairs of adjacent sides are equal. The diagonals are unequal. The diagonals are perpendicular to each other. The angles at the ends of the shorter diagonal are equal. The angles at the ends of the longer diagonal are unequal. The unequal angles are bisected. The equal angles are not bisected. That's about a kite. Next, trapezium. Trapezium. A quadrilateral in which exactly a quadrilateral in which you don't have to say exactly, a quadrilateral in which one pair of opposite sides are parallel. So a trapezium is a quadrilateral in which one pair of opposite sides are parallel. So this is a scalene trapezium. This one is a scalene trapezium. This is a right trapezium. This one is an isosceles trapezium. Please make a note and let me know. Done, children? So in an isosceles trapezium, we see that one pair of opposite sides is parallel and the non-parallel sides are equal. A trapezium in which the non-parallel sides are equal is an isosceles trapezium. Parallel sides will not be equal. The non-parallel sides will be equal. So in a trapezium, if the non-parallel sides are equal, it's an isosceles trapezium. Yeah, next one. So in a parallelogram, both the pairs of opposite sides are parallel. A quadrilateral in which both pairs of opposite sides are parallel is a parallelogram. The other quadrilaterals, rhombus, rectangle, and square, all are parallelograms. Rhombus, rectangle, and square are special parallelograms. Rhombus, rectangle, and square are special parallelograms. A rhombus is a parallelogram in which all sides are equal. A rectangle is a parallelogram. One angle is a right angle. A square is a parallelogram in which all sides are equal and one angle is a right angle. In rhombus, all sides equal. In rectangle, one angle is a right angle. In a square, put both of this together. All sides equal and one angle is a right angle. Rhombus, rectangle, and square are special parallelograms. Right on? Finish writing, children? Nobody is responding.
Completed, ma'am.
Okay, thank you. All right. All right. We're not going to see the proof for the theorem. We'll just see the statement and we'll understand what should be given and what is the result if certain things are given. Now let's first state the midpoint theorem. The line segment joining the midpoints of any two sides of a triangle is parallel to the third side and equal to half the length of the third side or half of the third side, equal to half of the third side. The line segment joining the midpoints of any two sides of a triangle is parallel to the third side and equal to half of the third side. Okay, so triangle ABC, we'll say that D is the midpoint of AB, given D is the midpoint of AB. We are also given that E is the midpoint of BC. Now, if these two information is given, then we can conclude that this is the line segment joining the midpoints. This is the line segment joining the midpoints. Where is the midpoint D? Or D is the midpoint of which side? D is the midpoint of AB. And E is the midpoint of BC. So now which is the third side which we have not still spoken about? It's AC. The third side is that side which we have not still spoken about. See, we're given that D is the midpoint of AB. The three sides of this triangle are AB, BC, and AC. It's given that D is the midpoint of AB. E is the midpoint of BC. So if this is given to us, then DE is parallel to the third side. DE is parallel to the third side, and the length of DE will be equal to half the length of the third side AC. The third side is that side on which we don't have the midpoints. So if we're given that D is the midpoint of AB, E is the midpoint of BC, the result is, if this is given to us, then the result is DE, see here, DE will be parallel to the third side. The third side is AC because we have AB, BC here. So the third side is AC. DE is parallel to AC and DE is equal to half of AC. These are the results which you can get using the midpoint theorem. So to use the midpoint theorem, you should have two things. That is, you should know the midpoints of any two sides of the triangle. You should know the midpoints of any two sides of the triangle. So if you know the midpoints of two sides of the, if you know the midpoints of any two sides of a triangle, then the line segment joining the midpoints will be parallel to the third side, and the length of that line segment will be equal to half the length of the third side. See here, take this triangle. Say M and P. Okay, so it's given that Q is the midpoint of PN, and it's also given that R is the midpoint of MN. If we are given this information, this is enough to use the midpoint theorem, to use the results of the midpoint theorem. This is sufficient. This information is sufficient. We have the midpoints of two sides of the triangle. Q is the midpoint of PN, R is the midpoint of MN. These two should be given to us. Then the result is the line segment joining the midpoint. So R is the midpoint, Q is the midpoint. So RQ is the line segment joining the midpoints. So the result by the midpoint theorem is RQ is parallel to the third side MP, and RQ is equal to half the length of the third side MP. RQ is parallel to MP, and RQ is equal to half the length of the third side MP. These are the results by the midpoint theorem. Make a note, children. Please write down. Finished?
Completed.
Yeah. So the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and equal to half the length of the third side. So to use the midpoint theorem, we just need to know the midpoints of any two sides of the triangle. If we know that, then we can use the results of the theorem. Next is the converse of midpoint theorem. Converse of midpoint theorem. The line through the midpoint of one side of a triangle parallel to the second side. Bisects the third side. So supposing we are given that D is the midpoint of BC. Okay. Now we draw a line through D parallel to the second side AB. We draw a line through D, through this midpoint D, we draw a line which is parallel to the second side AB. Okay. And let's say that the line meets the third side at E. So if we are given that D is the midpoint of BC, and if we are also given that DE is parallel to the second side AB, then the result is E is the midpoint of AC. These two should be given. Then this is the result. E is the midpoint of AC. So to use the converse of midpoint theorem, it's enough if you know the midpoint of any one side of the triangle. So here we know that D is the midpoint of BC. Then there is a line through D parallel to the second side of the triangle, parallel to AB. Through D, we have a line parallel to the second side AB. So if we have both of these, if it's given that D is the midpoint of BC and DE is parallel to AB, given these two, then the result by converse of midpoint theorem is that E is the midpoint of the third side AC. E is the midpoint of the third side AC. The line drawn through the midpoint of one side of a triangle. So this is the line. This is the line drawn. This is the line drawn through the midpoint of one side of the triangle. The line drawn through the midpoint of one side of a triangle parallel to the second side. If this line is parallel to the second side, then it bisects the third side. This line will bisect the third side. That means it will meet the third side at its midpoint. This line will meet the third side at its midpoint. So it should be known that D is the midpoint of BC. It should be given that D is parallel to AB. Then the result by the converse of midpoint theorem is that E is the midpoint of AC. Bisects means cut into two equal halves, which means E is the midpoint of AC. Okay. Now say in this figure, we are given that S is the midpoint of PR. It's given that S is the midpoint of PR. It's given. Then a line through S is parallel to the second side QR. This also is given. And the line through S, which is parallel to the second side QR, it meets the third side at T, suppose. So if we know that S is the midpoint of PR, and if it's also known that ST is parallel to the second side QR, then the result by the converse of midpoint theorem is that T is the midpoint of PQ. See, T can be any point on PQ, no? T can be any point on PQ. But if you have these conditions in the figure, then T will be the midpoint of PQ. T is the midpoint of PQ. Yeah, please write down, children. This is when you use the converse of midpoint theorem. If you know the midpoint of one side of the triangle, and if you have a set of parallel lines like this, then you can use the converse of midpoint theorem. When you know the midpoints of two sides of a triangle, then you can use the midpoint theorem and write the results. So when do we use the midpoint theorem? When we know the midpoints of two sides of a triangle. Then we use the midpoint theorem and we write the results. When you know the midpoint of only one side of the triangle, and through that midpoint, if you have a line parallel to the second side, if you have these two, then you can use the converse of midpoint theorem and write the result that whatever is a point where it meets, so here in the first figure, E is the midpoint of the third side AC. Or in the second figure, T is the midpoint of the third side PQ. The third side is bisected. That's a result. That's the only result. The third side is bisected. Yeah, finish writing and let me know. All right. So at this point, we have understood the definitions of certain special quadrilaterals, namely kite, trapezium, parallelogram, rhombus, rectangle, and square. We have seen their definitions. All right. And we have also understood how and when to use the midpoint theorem and the converse of midpoint theorem. Now let's use these theorems in some questions. Okay. Look at this one. ABCD is a quadrilateral in which PQ, look at the figure. As I read, look at the figure. ABCD is a quadrilateral. Okay. In which PQRS are the midpoints of AB, BC, CD, and DA. So that means P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of CD, S is the midpoint of AD. AC is a diagonal. AC is a diagonal. Show that SR is parallel to AC. SR, you should show that SR is parallel to AC. And SR is equal to half of AC. You must prove that SR is parallel to AC and SR is equal to half of AC. Then you should prove that PQ is equal to SR. PQ is equal to SR. And then you must prove that PQRS is a parallelogram. PQRS is a parallelogram. So let's do it one by one. Now remember that the midpoint theorem and the converse of midpoint theorem are used in triangles, not quadrilaterals. Okay, in a triangle, we use the midpoint theorem and the converse of midpoint theorem in a triangle. Okay, now in triangle ADC, in triangle ADC, Okay, in this triangle ADC, we know that S is the midpoint of AD, R is the midpoint of CD. So when you know the midpoints of two sides of a triangle, we can use the midpoint theorem. Therefore, by the midpoint theorem, the line segment joining the midpoints, SR, because S is the midpoint of AD, see the triangle is ADC. These are the two sides of the triangle where we know the midpoints, S and R. So the line segment joining the midpoints, SR, is parallel to the third side AC. So SR, by the midpoint theorem, SR is parallel to AC and SR is equal to half of AC. That's they're the direct results by the midpoint theorem in triangle ADC. So we finished the first one. Now repeat this in the triangle ABC. Use the midpoint theorem in triangle ABC. In triangle ABC. Apply the midpoint theorem in triangle ABC. So say the same thing. P is the midpoint of ABC in triangle ABC. So the sides are AB, BC, and AC. These are the three sides of the triangle ABC. Now we know that P is the midpoint of AB. P is the midpoint of AB. And Q is the midpoint of BC. So this is the third side. AC is the third side. So the line segment joining the midpoints, PQ. This line segment joining the midpoints is parallel to the third side AC and equal to half the length of the third side AC. So the result by the midpoint theorem is that PQ is parallel to AC and PQ is equal to half of AC. Using the midpoint theorem in triangle ABC. In triangle ABC, P is the midpoint of AB, Q is the midpoint of BC. So when we have the midpoints of two sides of a triangle, we can use the midpoint theorem. And the results are PQ is parallel to AC and PQ is equal to half of AC. So what do we have now? PQ is parallel to AC and PQ is equal to half of AC. So here you can see we've already proved that SR is equal to half of AC. We've already proved SR is equal to half AC here. Now we've proved that PQ is equal to half AC. So both PQ and SR equals half of AC. Both PQ and SR equals half AC. That means PQ is equal to SR. That means PQ is equal to SR. Now to prove that PQRS is a parallelogram, we have certain criteria. To prove that a quadrilateral is a parallelogram, we have certain criteria. One of which is, I'll tell you the criteria as and when we encounter, okay, a question like that. So now in a quadrilateral, see, in general, the definition of a parallelogram is that both the pairs of opposite sides are parallel. A parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. That's a definition of a parallelogram. But a parallelogram also has other properties. There are other properties also of a parallelogram. So in a parallelogram, opposite sides are equal. So we'll see the properties, the different properties later. Now I'll tell you one of the criteria. When can you call a quadrilateral a parallelogram? So in a quadrilateral, if one pair of opposite sides are parallel and equal. Okay, so you have a quadrilateral. You have a quadrilateral. Now, it's not that, yeah, this looks like a parallelogram. Yeah, so it's a parallelogram. No, no. You must say why it is a parallelogram with reasons. It's not that it looks like a parallelogram, so it's a parallelogram. Now, in this quadrilateral, if you are able to prove that one pair of opposite sides is parallel and equal, one pair of opposite sides is parallel and equal, then the quadrilateral is a parallelogram. There are many criteria for a quadrilateral to be a parallelogram. This is one of the criteria. So in PQRS, in the quadrilateral PQRS, okay, in the quadrilateral PQRS, we have proved that SR is parallel to ACC. We have proved that SR is parallel to AC. Oh, sorry. Yeah, we have proved that SR is parallel to AC. And we've also proved that PQ is parallel to AC. PQ is also parallel to AC. SR is parallel to AC. PQ is also parallel to AC. So SR parallel to AC, PQ parallel to AC. That means SR is parallel to PQ. SR is parallel to PQ. So in PQRS, we have proved that one pair of opposite sides is parallel. One pair of opposite sides is parallel. SR is parallel to PQ. SR is parallel to PQ. SR is parallel to PQ. And we've already proved that PQ is equal to SR. PQ is equal to SR, we've already proved. So in quadrilateral PQRS, one pair of opposite sides is parallel and equal. Therefore, PQRS is a parallelogram. Yeah, children. Let me just read through the proof again for you. So this is the question given, this one. Okay, so you need to start off like this. Whenever it's a proof, write down what is given, what is to be proved, construction, and other things. Okay, so this is the order: given, to prove, construction, proof. There's a question. Okay. Okay, so the diagram you can see here, we have joined AC. Maybe in the question figure, maybe the diagonal AC is not connected. That's why construction join AC. Construction joined AC. Okay, so you need to draw the diagram and join AC. If it is already joined in the figure, you don't have to say construction join AC. If it is not joined, then you'll have to say construction join AC and join it. Construction join AC. You can write it here and draw the figure. Now, given, what is given? Quadrilateral ABCD is given to us. P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of CD, S is the midpoint of AD. All this is given to you. What do you have to prove? So whatever is to be proved, right here. To prove. To prove. Next, the proof. So as we understood, first take up the triangle ACD. In triangle ACD, write out the midpoints. S is the midpoint of AD. In triangle ACD, S is the midpoint of AD. R is the midpoint of CD. Therefore, by midpoint theorem, SR is parallel to AC and SR is equal to half the length of AC. They are the results by the midpoint theorem. The line segment joining the midpoints is parallel to the third side and equal to half the length of the third side. Now, you need not mark A and B now. See, because you don't know, like, how do you know that you'll have to mark this as A and B? How do you know that you're going to use this later? So you will not be marking it. When you write, you don't mark A, B now. You can come back and mark it later when needed. Next, in triangle ABC, P is the midpoint of AB, Q is the midpoint of BC. Therefore, by midpoint theorem, PQ is parallel to AC and PQ is equal to half the length of AC. Now, what is it we have to show? We need to show that SR is parallel to AC, right? SR is parallel to AC. That we've already done here. SR is parallel to AC. SR is equal to half AC. It's already over. We finished that. PQ is equal to SR. We need to show that PQ is equal to SR. Right? So now I've marked these points. So now come back and mark A, B, these results A, B, C, and D. Compare A and C. Compare A and C. So from A and C, SR is parallel to AC, PQ is parallel to AC. So from A and C, from the results A and C, SR is parallel to PQ. SR is parallel to PQ from A and C. Now from B and D, SR is equal to PQ because SR is half AC, PQ is also half AC. So from B and D, sorry. So from B and D, SR is half AC, PQ is also half AC. So SR is equal to PQ. SR is equal to PQ. So we have to prove that SR is equal to PQ, no? We have done that here. Now, if one pair of opposite sides is parallel and equal, then the quadrilateral is a parallelogram. If one pair of opposite sides is parallel and equal, then the quadrilateral is a parallelogram. So you can see here, in PQRS, one pair of opposite sides, that is PQ and RS, they are parallel and they are equal. That is from 1 and 2. So I've marked these results 1 and 2. So from 1 and 2, PQRS is a parallelogram. Yeah, please write down, children. It's NCRT. I don't remember the exercise number. 8.2, I think, if I'm not wrong. You can check your textbook. So write the exercise number. Question number 1. You can directly start with the solution. Or if you want to write the question, leave some space for the question. Take down the proof. Take down the solution. You can always copy the question later into your book. I'll just come back in 2 minutes. Please write, children. Again, children, use the emoji. Raise your hand. Lakshana, Krishna Priyan, Srivatsan, Sadhna, Sabarna, Aragamai, Sahana, Hariharan, Niveda. Who's the meeting guest? I can't see the name. Who's this? Bhavishya, are you there? Okay, no response. Please continue, children. Yeah. Just come back in some time. 2-3 minutes. I'll come back. Please write. So from the first proof, children, what you need to remember is in any quadrilateral, okay? Any quadrilateral. Okay, so this is any quadrilateral ABCD. Now the figure obtained by joining the midpoints of the sides of this quadrilateral. So let's mark off the midpoints. So say M is the midpoint of AB, N is the midpoint of BC, O is the midpoint of CD, and P is the midpoint of AD. Now, so ABCD is any quadrilateral. M, N, O, P are the midpoints of the sides of the quadrilateral. Now let's join the midpoints. So there are 4 points, 4 non-collinear points, or will form a quadrilateral. So let's join these 4 points. Now this quadrilateral MNOP will always be a parallelogram. This will always be a parallelogram. So if you have a quadrilateral and you join the midpoints of the sides of this quadrilateral, the new quadrilateral formed is a parallelogram, always. ABCD is any quadrilateral. We have a new quadrilateral formed by joining the midpoints of the sides of ABCD. That new quadrilateral MNOP is a parallelogram. ABCD is not a parallelogram. ABCD is just is any quadrilateral. ABCD is not a parallelogram. ABCD is any quadrilateral. MNOP, the quadrilateral MNOP, which is formed by joining the midpoints, will always be a parallelogram. Is the result. That's what we have proved here. ABCD is a quadrilateral. Then PQRS is a parallelogram. The outside quadrilateral. ABCD is a quadrilateral. PQRS is a parallelogram. Okay. Look at this one. ABCD is a rhombus. ABCD is a rhombus. Okay. ABCD is a rhombus. PQRS are the midpoints of AB, BC, CD, AD. So P, AB, Q, BC, R, CD, S, AD. Show that PQRS is a rectangle. Show that PQRS is a rectangle. So if the outside quadrilateral is a rhombus, ABCD is a rhombus. And how did we get PQRS? By joining the midpoints of the sides of the rhombus. Then this new quadrilateral is a rectangle, is what we have to prove. If ABCD is a rhombus, then PQRS, which is formed by joining the midpoints of ABCD, is a rectangle, is what we have to prove. And the definition of a rectangle is a parallelogram in which one angle is a right angle, is a rectangle. A parallelogram in which one angle is a right angle is a rectangle. So to prove that a quadrilateral is a rectangle, you need to first prove it's a parallelogram. See, to prove that a quadrilateral is a rhombus, rectangle, or a square, you should first prove that it's a parallelogram. To prove that a quadrilateral is a rhombus or a rectangle or a square, you need to first prove that it's a parallelogram. So to prove that the quadrilateral is a rectangle, prove that it's a parallelogram, and then in the parallelogram, if one angle is a right angle, then it's a rectangle. Okay. So to prove that PQRS is a rectangle, we need to first prove that PQRS is a parallelogram because that's a definition. A rectangle is a parallelogram in which one angle is a right angle. One angle is equal to 90 degrees. So first prove that PQRS is a parallelogram. Now for that you need to connect any one of the two diagonals, AC or BD. You should join the diagonal of the outer quadrilateral, not the inner one. Don't join the diagonal PR or QS. No, that will not help. Do not join the diagonal of the inner quadrilateral, the outer one. Join the diagonal of the outer quadrilateral. So you can join AC or BD, anything. Join AC or join BD. Now in triangle ABD, use the midpoint theorem. Because P is the midpoint of AB, S is the midpoint of AD. So in triangle ABD, by the midpoint theorem, PS is parallel to BD and PS is equal to half of BD. Similarly, in triangle BCD, below BCD, Q is the midpoint of BC, R is the midpoint of CD. Again, by the midpoint theorem, QR is parallel to BD and QR is equal to half of BD. In triangle BCD, Q midpoint of BC, R midpoint of CD. Therefore, QR, the line segment joining the midpoints, is parallel to the third side BD and equal to half the length of the third side BD. Now you can see that PS is parallel to BD, QR is parallel to BD. PS is parallel to BD, QR is also parallel to BD. So that means QR or PS is parallel to QR. PS is parallel to QR. PS is half BD, QR is also half BD. That means PS is equal to QR because both of them are equal to half of BD. So PS is equal to QR. So we have proved that in quadrilateral PQRS, one pair of opposite sides is parallel and equal. Therefore, PQRS is the parallelogram. PQRS is a parallelogram because we have proved that one pair of opposite sides, PS and QR, they are parallel and they are equal. So PQRS is a parallelogram. Okay, so we are, like about 70% done. We proved it's a parallelogram. Now we just have to prove that one angle is a right angle. So you can either prove this is 90 degrees or this is 90 degrees or this is 90 or this is 90. Because you proved it's a parallelogram. Next you'll have to prove that one angle is a right angle. If you prove one angle is a right angle, then PQRS is a rectangle. So now how do you prove that this angle is 90 degrees? Any one angle, say like we have to prove that this is 90 degrees. Okay, we have to prove that this is 90. Now listen carefully. Now let me mark this angle 1. Very simple proof. 2, 3, 4, 5, and 6. Now, angle 1 is equal to angle 2 because now is AB equal to AD, children? Tell me, is AB equal to AD? If you don't answer, I can't make out if I'm not audible or I'm not clear in my explanation. Or if my question is not clear. Is AB equal to AD is my question. Yes or no? Okay. So AB is Yeah, AB is equal to AD because ABCD is a rhombus. Then half of AB will be equal to half of AD. Now tell me what is half of AB? AP. Or you can say PB also because P is the midpoint. P is the midpoint of AB. So half of AB, you can say AP or BP. And half of AD, you can say is AS or DS. We'll write AS. So like this, AP is equal to AS. AP is equal to AS. This side is equal to this side. Therefore, angle 1 is equal to angle 2. Angle 1 is equal to angle 2. Now, next we'll prove that angle 5 is equal to angle 6. We'll prove that angle 5 is equal to angle 6. For that, let's take up this triangle. Let's take up this triangle and this triangle and show that they are congruent. Once you show that they are congruent, angle 5 is equal to angle 6, CPCT. So BP of this triangle is equal to SD of this triangle. Same reason, because AB is equal to AD, half of AB is equal to half of AD, so BP is equal to SD. Same reason, BQ is equal to DR. BQ of this triangle is equal to DR of this triangle. And then PQ is equal to SR. Because we proved that PQRS is a parallelogram. We've already proved that PQRS is a parallelogram. And in a parallelogram, opposite sides will be equal. In a parallelogram, opposite sides are equal. So PQ is equal to SR because PQRS we proved is a parallelogram. And in the parallelogram, opposite sides are equal. So these two triangles are congruent by the SSS congruence criterion. So angle 5 is equal to angle 6, CPCT. Angle 5 is equal to angle 6, CPCT. Now, angle 1 plus angle 3 plus angle 5 is 180 because straight line. Angle 2 plus angle 4 plus angle 6 is also 180 because straight line. So 1 plus 3 plus 5 is 180. 2 plus 4 plus 6 is also 180. That means these two are equal. Now, this angle 2, in the next step, you can replace angle 1 because angle 1 is equal to angle 2. And in the next step, you can also replace angle 6 with angle 5 because they're equal. Angle 6 is equal to angle 5. So you can cancel angle 1 and angle 1 gets cancelled on either sides. Angle 5 and 5 gets cancelled on either sides. So we have this result, angle 3 is equal to angle 4. So we proved that angle 3 is equal to angle 4. Now, PQRS is a parallelogram. PQRS is a parallelogram already. We proved. Now, in the parallelogram, angle 3 and angle 4, they are adjacent angles. Now, we know that in a parallelogram, adjacent angles are supplementary. Or you can say these two lines are parallel and this is the transversal. So, co-interior angles are supplementary. PQRS is the parallelogram. So we already have opposite sides parallel. So parallel lines, transversal. Co-interior angles are supplementary. Angle 3 plus angle 4 is equal to 180. Or you can also say in the parallelogram, adjacent angles are supplementary. So 3 plus 4 is 180, whatever reason. So angle 3 plus angle 4 is 180. But angle 3 and 4 are equal angles. They are equal and they are supplementary. 3 and 4 are equal angles. And 3 and 4 are supplementary angles. That means they have to be 90 each because they're equal, 90, 90. And they're supplementary, 90 plus 90 is 180. So angle 3 plus angle 4 is 180. Angle 3 plus angle 3 is 180 because 4 and 3 are equal angles. Angle 3 is equal to angle 4. So twice of angle 3 is equal to 180. Angle 3 is equal to 180 by 2, 90 degrees. So you have proved that angle 3 is 90. So if angle 3 is 90, it means PQRS is a parallelogram in which one angle is a right angle. Angle 3 is equal to 90 degrees. One angle is a right angle. Therefore, PQRS is the rectangle. So this is one way of doing. Or what you can do is, rhombus. Okay. Okay. So that first part is the same, children. So the first part is to prove that PQRS is a parallelogram. The first part is to prove that PQRS is the parallelogram. That remains the same. So after that, what you can do is join AC. Join the diagonal AC. Join the diagonal AC. Now show that this one is a parallelogram. Prove that this one is a parallelogram. We know that in a rhombus, the diagonals are perpendicular to each other. They bisect at right angles. So we already know that this is a right angle. This is 90 degrees. Because the outer one, ABCD, is a rhombus. So this is 90 degrees. We already know this is 90. So this is 90. This is 90. Now, once you prove that this one is a parallelogram, if you prove that this is a parallelogram, in a parallelogram, opposite sides are equal, opposite angles are equal. In a parallelogram, opposite sides are parallel, opposite sides are equal, opposite angles are equal. So if you prove that this one is a parallelogram, this angle is 90 degrees because the diagonals of a rhombus are perpendicular to each other. Now, if you prove that this is a parallelogram, opposite angles are equal. So this also will be 90. So like this, you can prove that in parallelogram PQRS, one angle is a right angle. So PQRS is the rectangle. Yes, children. Please start working. I'm not reading through this proof. Please read, understand. It continues. The proof does not end here. It continues. It ends here. Once again. Yeah, so it ends here. And this is that alternate solution. The alternate solution, I told you, no, one more. So that one is here. Yeah. Yeah, please work. Can we move to the next slide, children? Please respond. Can we move to the next slide?
Yes, ma'am. Yes, ma'am.
Okay, children, don't get confused with, this 1, 2, 3, 4, and this 1, 2, 3, 4. Don't get these are different. I've just marked this one. This one is different from this one. Okay, this one here I've marked the angles 1, 2, 3, 4, 5, 6. This result is one here. There's nothing between this. There's no meaning. There's no connection between this one and this angle one here. Okay. Yeah. Please work. So children, you can remember the proof in 3 parts. So you have to take up this triangle. You'll have to take up this triangle and show that angle 1 is equal to angle 2. Show that 1 is equal to 2. And to show that angle 1 is equal to angle 2, you need to prove that AP is equal to AS. And what is AP? It is half of AB. And what is AS? It is half of AD. So you need to start like this. AB is equal to AD. Half of AB is equal to half of AD. Therefore, AP is equal to AS. So in a triangle, when two sides are equal, the angles opposite to them are also equal. So angle 1 is equal to angle 2. Next, you have to prove that angle 3 is equal to angle 4. You need to prove 1 is equal to 2 and 3 is equal to 4. So angle 3 is an angle of this triangle. Angle 4 is an angle of this triangle. So you'll have to show that these two triangles are congruent. And hence CPCT angle 3 is equal to angle 4. So for that, you need to write BP is equal to DS. BP is equal to DS. So BP is equal to half of AB. And DS is half of AD. And AB is equal to AD. AB is equal to AD because in a rhombus all sides are equal. So you start with AB equal to AD. And then half of AB equals half of AD. And so BP equals DS. Because P, Q, R, S are the midpoints. Because P is the midpoint, half of AB is BP or AP. Half of AD is AS or DS. You can write anything, whichever is suitable for that situation. So like this, we have BP equal to DS in these two triangles. And in the same way, you'll have to show that BQ is equal to DR. BQ is equal to DR in the same way. And then PQ is equal to SR. Because opposite sides of the parallelogram are equal. We proved that PQRS is a parallelogram already. We proved it's a parallelogram. So the opposite sides are equal. Therefore, these two triangles are congruent by SSS criterion, and angle 3 is equal to angle 4 CPCT. Now, 1 plus 5 plus 3 is 180, and 2 plus 6 plus 4 is 180. So that means 1 plus 3 plus 5 is equal to 2 plus 4 plus 6. So we proved that 1 is equal to 2. I've called this A, and 3 is equal to 4. I've called it B. So from A and B, or using A and B, you can replace 2 with 1 because 2 is equal to 1. And you can replace 4 with 3. 4 with 3 because 3 is equal to 4. So angle 1 and angle 3 gets cancelled on both the sides. So we have angle 5 is equal to angle 6. Angle 5 is equal to angle 6, but they are co-interior angles. Angle 5, you can say adjacent angles. They are co-interior angles, but when you say parallelogram, they are the adjacent angles of parallelogram. Adjacent angles of parallelogram PQRS are supplementary. In any parallelogram, adjacent angles are supplementary. So in parallelogram ABCD, if ABCD is a parallelogram, adjacent angles, angle A plus angle B is 180, angle B plus angle C is 180, angle C plus angle D is 180, angle D plus angle A is 180. Adjacent angles are supplementary. So since PQRS is a parallelogram, we proved Adjacent angles 5 and 6, they are supplementary. Right, adjacent, not co-interior. Adjacent angles are supplementary. 5 plus 6 is 180, but 5 and 6 are equal. So that means 5 plus 5 is 180. 6 can be replaced with 5. So twice of angle 5 is 180. So angle 5 is equal to 180 by 2, which is 90. So we have proved that in the parallelogram PQRS, angle 5 is 90. That means one corner is a right angle. Therefore, it's a rectangle. So in parallelogram PQRS, one angle is a right angle. QPS is a right angle. Therefore, it's a rectangle. That's the definition of a rectangle. A rectangle is a parallelogram in which one angle is a right angle. So we have proved that PQRS is a parallelogram already. PQRS is a parallelogram in which one angle is a right angle. So we proved that this angle is 90 degrees. So it's a rectangle. If you have not finished the proof fully, children, take a picture. Yeah, the alternate proof, till here it's the same. That is to prove that PQRS is a parallelogram. This is common to both the methods. Proving that PQRS is a parallelogram. Okay, so it's the same slide here. Take a screenshot. It's time. Please complete this by the next class. Yeah. So this is the different part of the proof. Till proving that PQRS is a parallelogram, it's the same. Then after that, what we do, we also join the diagonal AC and we show that PNOM is a parallelogram. We show that PMON is a parallelogram. So once you show that this is a parallelogram, this is 90 degrees because the diagonals of a rhombus intersect at right angles. So once you prove that this is a parallelogram, opposite angles are equal. So this is also 90. So in the parallelogram PQRS, we prove that one angle is a right angle. So it's a rectangle. Yeah. So this is the alternate proof. Take a picture, children. Yeah. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you. Good night.
Thank you, children. Good night. Thank you, children.
Thank you,
Good
ma'am.
night. Thank you. Good night.
Thank you.
Good night, children. Thank you.
Thank you, ma'am.
Thank you. Good night.